Hello. For my Capstone project, I created a disc tracker. Basically what it was supposed to do is, for disc golf, it will track a disc, a video of a disc being thrown. And that's exactly kind of what I got it to do. So, it would take a disc like, a video like this, with a disc being thrown, and then draw a line where it went. So, if you look at it, it kind of traveled up like this, went down, and hit the ground. That's the kind of path that I wanted, and it did kind of get that. So this is after it analyzed that image, or that video. You can see that it just traveled upwards in an arc, and then came down, hit the ground, but it did kind of, it's not exactly perfect because it did, detect the disc down at the bottom right, even though it wasn't there. And it kind of fudged up in the middle where you can kind of see it drew, a line just kind of jaggeded. So, let me just give you a brief overview of my program, what it actually, how it actually looked. It was just, really just a command line program, just because I didn't have the time to actually start developing a GUI interface, because I would like to put this on a mobile application. Basically what, it had to do was you would, from the command line, you could do a series of options. You could either analyze the video, load, save, create disc color data, or you could show the current disc color data, or you could even see how many colors that it currently was in the disc color data. So here's just an example of me loading in the disc color data, and then analyzing a video. This is how it kind of works. It'll just go through the video, slowly showing it. It will take the time to analyze the video, and then, marking the locations that it was at. And eventually, once it's done processing it, it will show the line that the path that it traveled, as you can see, and it does that. It shows this nice red path showing it. I just exit the program from there. So, like I said, the first thing I did was load the disc color data. And the disc color data is basically this, for this specific image, or for this specific disc. As you can see, this is kind of what it is. The disc was a red disc, but when I analyzed the disc, the text on it is blue, so that's why there's a lot of blue currently. But it will show you all this red that it is looking for in the disc. You can kind of see that there is a lot of red that it is looking for, albeit with a little bit of blue that it has to look for as well. So, basically how we created this disc color data was by taking a video of the disc top down, and then looking for circles in that image, or in that video. As you can see here, this blue circle represents what it was looking at, and it would take all that color inside of that circle and add it to the disc color data. That's why there is a lot of blue in there, because the text on it is blue, like I said. So it continuously do that as well to create the disc color data, or even add more onto the current disc color data that you loaded in. So when it's actually analyzing the video, this is kind of the stuff that it is detecting. So you can actually see it. You can see that it is detecting it. You have this yellow ring that represents what it thinks the disc is, and you got this red crosshair that points to the center of that. So it works fairly well. There are plenty of times when it is off a lot, like right, where is it? It should be coming up. Yeah, right there. It's not even on the disc at all. That one even further away. So it's not the best, but for the majority of the time, it does at least point to the disc, and the disc, a lot of the time, I would say like about 50% of the time, is quite accurate, or maybe even less than that, but around there. You can see that it is tracking the image quite well, I think, and it will continue to do that. So let me break down how this actually goes about tracking the disc. You have this image, per se. It's going to analyze this image by first removing the colors that aren't in the disc color data, like so. You see all this red, you see a blue, you see a bit of brown over here. From there, it will make that black and white, like so. You can see it all still there. Then it will expand the white based on if there is enough white around. So you'll see right here that this white expands, but this stuff doesn't around here because there is not enough white. There's only enough white right over here, so it expands that stuff over there. From there, you need to create an edge image, which is exactly what it sounds like. It's going to have all the edges in the image. So I take an edge image of this, like so, and it comes out like this. You see all these white lines, which represents edges that it has detected. Next, what you got to do is you AND these together. So basically, whenever there's white in this left image and white in this right image, it keeps it. Otherwise, it will turn to black. So when you AND these two together, you get this image. You can see it's very nice isolated. You don't have to look or analyze much more data than just this. So you can look just where you need to. But the edge image definitely, you can definitely tell this is a different edge image that I used, where detected less edges, and you can see that it kind of turns out better because this disk is smaller. There's less edges here where I don't need them. The disk color data is the same, but this program really does rely heavily, I think, on both the disk color data and the edge image itself. So those are the two things that I would need to work out to improve this program, really. Like I said, it turns out fairly nicely. I think overall this program worked quite well because it does get a nice path of the disk, although not perfect, but it does do its job.